Hi everyone, is my voice audible? Hi everyone, is my voice audible?
Hi everyone.
Okay, let us start our class. So today's topic is syllogisms. But before going into syllogisms, first we should know what are the basics of syllogisms. Okay, coming to the first point, all statements are always true. So it means whatever statements we get under syllogisms, we should consider them as true. That is the first basic and most important point. Next, if a conclusion is false in one situation, you can finally consider it as false. So the meaning of this one is whenever you get any conclusion as false, then the final answer for that particular conclusion is false. No matter whether it becomes true or not after some time, but the final answer for that one is false. Next, if it is true, then you should cross check whether it becomes false or not. For example, if you got any conclusion true, then you should not take it as true finally. You should check whether it becomes false or not. Suppose if it becomes false, then you should consider it as false only. If it doesn't becomes false, then only you should take it as true. That is about third point. Now coming to fourth point, we should always give priority to minimum intersection diagram. So minimum intersection diagram means you should not take any unnecessary intersections in the given diagram. While solving the questions, you will get some more clarity. Let us go for the questions. Okay, first question. I'll explain some questions. After that, you try to do. So, coming to the first one, some calculators are stones. The first statement is some calculators are stones. With the help of Venn diagrams, we will be solving this. So first let us take calculators. These are calculators. Okay, some calculators are stones. So some calculators are stones means you should take minimum intersection. So whenever you find some, it means intersection is possible. Just remember one thing: if intersection is possible, then we can call some condition is possible there. Next, all calculators are pens. All calculators are pens means calculator circle should be inside pen circle. So this is a pen circle. All calculators are pens. That means any calculator should not be outside pens. Next, no calculator is an octopus. So no calculator is an octopus means you should take octopus circle separately. No calculator is an octopus. Okay, I am taking this octopus circle separately. No calculator is an octopus. So this is our minimum intersection diagram. From this, we should check for the conclusions. The first conclusion is no octopus is a stone. So no octopus is a stone means if those two circles are not intersecting, no means it should not intersect. Some means it should intersect. So no means as they are not intersecting, octopus and stone both are not intersecting. So as those are not intersecting, we can take this as true. But earlier, as I already said that whenever you get true, based on the syllogism's points, just check for the previous one, check for the third one. If it is true, suppose if we get it as true, then you should cross check whether it becomes false or not. We should check whether it can be false or not. So let us check. We got true. So when we got true, we should check whether it becomes false or not. As I already said, no condition means if it is not intersecting, then no is true. If it is intersecting, then no is false. So let us try to intersect that diagram. I'm just intersecting octopus and stone. I'm cross checking whether it becomes false or not. So in order to make it false, I'm intersecting octopus and stone. Okay, octopus and stone both are intersected. So as I already said that when no condition, if we have no, it should not intersect. Here it is intersecting. So as those are intersecting, first one becomes false. But in that scenario, our diagram should be true. Diagram can be true based on the statements. So if you check for the statements, some calculators are stones. So some calculators are stone means they are intersecting. Here they are intersecting. So some calculators are stones is correct only. First statement is correct. Next, all calculators are pens. So all calculators comes under pens. Calculator circle is in pen circle. So this is also correct only. Next, no calculator is an octopus. Calculator circle and octopus circle both are not intersecting. No means should not intersect. So this is also correct only. As all our statements are true in the given diagram, the diagram is correct only. In correct diagram, we got first conclusion as false. So as we got first conclusion as false, based on the rules of syllogisms, whenever you get it false, you should take it false only. It will not be true anymore. So first one is false. First one doesn't follow. Next, second one, some pens are octopuses. Some pens are octopuses means again some means those should intersect. So you should check whether pens and octopus circle is intersecting or not. Pen circle and octopus circle both are not intersecting. As those are not intersecting, this is wrong. Some is wrong. Now, as we already got it as false, we need not check whether it becomes false or not. Because if we get false one time, you can take it as false finally. So answer for this one is neither 1 nor 2. Neither 1 nor 2. That means both 1 and 2 doesn't follow, which is option 3. Okay, is everyone clear with this? Can I go to the next question? Second question. This is the second one. Once try to do. First, you should take all the statements into diagrams. There, you should follow minimum intersection diagram. That means you should not give unnecessary intersections. If anyone got the answer, you can comment it here. Syllogisms is most important topic. You almost get in all the exams, whatever exam you take. For example, any government exams or any campus recruitment exams. So whatever, even UPSC exams. So whichever exam you take, definitely you get questions from syllogisms topic. Okay, if anyone got the answer, you can comment it. Okay, let us check how to do. So the first statement says that all warriors are politicians. So all warriors are politicians. So all warriors comes under politicians. This is the first statement. Next, coming to the second statement, all leaders are knights. As we don't know any knights and leaders here, I am moving to the other statement. Third statement. Some knights are warriors. We have warriors here. So some means, as I already said, we should intersect. Some means intersection. No means not intersection. So some knights are warriors. Some knights are warriors means I'm just intersecting knights with warriors. Minimum intersection diagram. So I'm not giving any unnecessary intersections between knights and politicians. Some knights are warriors. Okay, third one is also over. First one is over. Next, let us go for the second one. All leaders are knights. All leaders are knights. All leaders are knights means complete leaders circle should be inside knight circle. So I'm taking leaders here. This is leaders circle. Leaders circle is inside knight circle. So this is a minimum intersection diagram. Okay, so this is our minimum intersection diagram. Based on this, let us check for the conclusions. Some warriors are leaders. Some warriors are leaders. So if you observe, warriors and leader circle both are not intersecting. Warriors and leader circle are not intersecting. Some means it should intersect. So as those are not intersecting, you can take this as false. First conclusion doesn't follow because warriors and leaders both are not intersecting. Next, some politicians are knights. Some politicians are knights. So some politicians are knights, we got it as true. Second conclusion follows. Second one is true. So as I already said that whenever you get something as true, you should check whether it becomes false or not. So let us check whether it becomes false or not. Okay, some politicians are knights becomes false when politicians and knights doesn't intersect. This one we got it as true. So this sum condition becomes false when these two doesn't intersect. Just remember one thing, sum means intersection is possible. Sum means intersection should be possible. Okay. No means it should not intersect. No means it should not intersect. Sum means it should intersect. Just remember those two things. So yes, some politicians are knights. It is correct because those are intersecting. Politicians and knights both are intersecting. Now what we should do means, in order to prove this false, we should remove that intersection. So let us remove that intersection. Okay, I am removing knights and politicians intersection. I am taking them separately. I removed politicians and knights intersection. I took them separately. So in this, second conclusion became wrong. Some politicians or knights became wrong because it is not intersecting. But we should check whether the diagram is correct or not. So let us check whether the diagram is correct or not. All warriors are politicians. Yes. First statement follows. Next, all leaders are knights. All leaders are knights. It is not possible in a diagram. So when any statement is going wrong in a diagram, it states that our diagram is wrong. So our diagram became wrong. Why means we tried to prove second conclusion false. So that means when our diagram is going wrong, it indicates that second one cannot be false. We cannot make second one false. So as we cannot make second one false, then it is true. You should accept that second conclusion is true. So answer for this one is only two follows is the correct answer, which is option 4. Option 4 is the correct answer. Okay, can I go to the next question? Is everyone clear with this? Okay, let us go to the next question. This is the next one. Third question. We have three statements and we have two conclusions. The first statement says that no nail is a cutter. It means no means intersection should not be possible. You should not intersect. So no means you should take them separately. Okay, let us check how to do. So the first one, no nail is a cutter. So no nail is a cutter means you should take nail and cutter separately. You should not intersect them. So this is nail and this is cutter. Next, all cutters are knives. So all cutters are knives means inside that cutter circle should be completely inside a knife circle because all cutters are knives. This is our second statement. Next, coming to the third statement, no cutter is a scissor. No cutter is a scissor. So that means you can take scissor separately. You can take scissor separately. Okay, you can take scissor somewhere here. No cutter is a scissor. So this is minimum intersection diagram. Now, based on this, we should check for the conclusions. No scissor is a knife. No scissor is a knife. So, no scissor is a knife means we got this one as true, because no means it should not intersect. Scissor and knife both are not intersecting. So, this is true. But based on the rules of syllogisms, when we got true once, we should check whether it becomes false or not. So, let us check whether it becomes false or not. This no condition becomes false when we intersect scissor and knife. If we intersect scissor and knife, those both becomes false. So let us check whether we can intersect scissor and knife or not. Okay, I'm intersecting scissor with knife. I'm intersecting scissor with knife. So now scissor and knife got intersected. So as those both got intersected, this no condition is wrong, because no means it should not intersect. But here they got intersected. Now in our diagram it became false. So we should check whether the diagram is correct or not. So let us go with the statements. First one, no nail is a cutter. So no nail is a cutter is correct only, because they are not intersecting. First one is correct. Next, all cutters are knives. Again, all cutter circle is inside knife circle. So this is also correct only. No cutter is a scissor. Scissor and cutter circle both are not intersecting. So as those both are not intersecting, this is also correct only. When all the statements are correct, our diagram is also correct only. This is correct diagram. So in correct diagram, we got first conclusion as false. We got one true and one false. Based on the rules of syllogisms, if it becomes false, you should finally take it as false only. So it is not true. This true gets vanished and you should finally consider it as false. So first conclusion became false. Next, second one. Some nails are knives. Some nails are knives means, again some means it should intersect. Nails and knives should intersect. But if you observe, nails and knives are not intersecting. So as those both are not intersecting, you should take it as false. Because some means it should intersect. Now here not intersecting, so it is false. When it is false once, you can directly take it as false. So answer for this one is, again both 1 and 2 doesn't follow. Neither 1 nor 2 is the answer. Option 3 is the correct answer. Okay, I hope everyone understood this. Let us go to the next question. Fourth one. Now we are discussing total 14 questions. 7 questions from syllogisms and 7 questions from coding and decoding. Again, here we have 3 statements. So try to take those 3 statements into one diagram. First statement says that all bricks are walls. First statement says that all bricks are walls. So first we should take all brick circle into wall circle with minimum intersection diagram. So all bricks. First we are taking bricks. Next, all bricks comes under walls. All bricks are walls. Next, all stones are walls. So you should take all stone circle inside wall circle only. Again, we are taking minimum intersection diagram, so that's why we should not intersect bricks and stones. So all stones are walls. Next, all candles are walls. All candles are walls means again you can take candles separately. But all candles should be inside wall circle only. So this is a minimum possible diagram, minimum intersection diagram. Now based on this one, we will check for the conclusions. First conclusion says that some walls are bricks. So as some walls are bricks, as those both are intersecting, some means it should intersect. Some means it should intersect. So as walls and bricks are intersecting, there is some common area between them. First conclusion is true. First conclusion is true. Next, when we get any conclusion as true, you should check whether it becomes false or not. So this some condition becomes false when those both doesn't intersect. So walls and bricks should not intersect. Should not intersect means I should separate them. So I'm taking bricks separately. Now here they are not intersecting. So this sum condition becomes false. Sum condition becomes false. First conclusion becomes false. But I should check whether this diagram is correct or not first. So let us check whether it is correct or not. All bricks are walls. All bricks are walls means first statement is becoming wrong. First statement is becoming wrong because all bricks are walls is wrong in a diagram. So as first statement is wrong, diagram is wrong. When we are trying to prove it as false and if the diagram becomes wrong, then that means that we cannot prove it false. You cannot prove it false. So it means when we cannot prove it false, you should take it as true only. So first one is true only. Next, coming to second one, some walls are candles. First one is definitely 100% true. No one can prove that as false. So as no one can prove that as false, the final answer for that one is it is always true. Again, I'm coming to our previous diagram. So first one is true. Next, some walls are candles. So some walls are candles means again walls and candles should intersect. Here those both are intersecting. So as those are intersecting, this is also correct only. Again, we cannot prove this false. We cannot separate walls and candles because here they clearly gave that all candles are walls. Okay, next. Some bricks are stones. Some bricks are stones. Here those both are not intersecting. Some means it should intersect. Some means it should intersect. But coming to our diagram, those are not intersecting. So as those are not intersecting, some bricks or stones is wrong. When it is wrong in one situation, you can directly take it as wrong, false. Next, no candle is brick. No candle is brick. So no candle is brick means again if you observe, it should not intersect. No means it should not intersect. So here it is not intersecting. Candles and bricks both are not intersecting. So as these both are not intersecting, we can take fourth one as true. Fourth one is true. But whenever we get true, we should check whether it becomes false or not. So let us check whether it becomes false or not. That means you should intersect candles and bricks. You should intersect candles and bricks. I am just intersecting candles and bricks. Now as these both are intersected, no candle is brick is wrong because no means what? No means it should not intersect, but here they are intersecting. So as those both are intersecting, you can take it as false. But we should check whether our diagram is correct or not. All bricks are walls. Yes, bricks are inside walls. Next, all stones are walls. Yes, stones are inside walls only. Next, all candles are walls. Yes, candles are inside walls only. So all the three statements are correct. When all the three statements are correct, our diagram is also correct only. When our diagram is correct and we are proving the last one as false, you should finally consider it as false only. Because in correct diagram, it became false. So when it becomes false in one situation, it is false everywhere. That's why answer for this one is only 1 and 2 follows. 1 and 2 follows is the correct answer. 3 and 4 are false. Okay, next one, fifth one. Fifth one is something different because here we have a word called possibility. So whenever we have a word called possibility, we should take it something differently, not like the regular syllogisms. It is something different. I will tell that afterwards. First, let us solve for the conclusion one. So till conclusion one, it is same. But coming to second one, I'll tell that separately. First, let us solve for conclusion one. Okay, for the first one, let us check. Let us take the minimum possible diagram, minimum intersection diagram. Some schools are classes. First one is some schools are classes. Some schools are classes means we should intersect schools and classes because some means intersection is possible. So some schools are classes. Next, some classes are teachers. Some classes are teachers. So some classes are teachers. Next, all teachers are students. Next one is all teachers are students. So all teachers comes under students. Now this is a minimum possible diagram. This is a minimum possible and also minimum intersection diagram. So from this we should check for the conclusions. Coming to the first conclusion, some students are classes. Some students are classes. So if you observe this one, some means it should intersect. So here it is intersecting. Some means it should intersect. Here students and classes are intersecting in a diagram. So as those both are intersecting, this is true. Some students are classes is true. Next, what we should do means we should try to prove that as false. So in order to prove that as false, some should be false means it should not intersect. So students and classes should not intersect. I'm just separating students and classes. Okay, students and classes are separated. I'm taking students separately. So here I took students. Now if you observe, in our diagram, the first conclusion is becoming wrong because students and classes are not intersecting. So it became false. But we should check whether our statement is correct or wrong. Statements. So coming to the first one, some schools are classes. Some schools are classes. Yes, they are intersecting. So this is correct only. Next, some classes are teachers. Again, some classes are teachers is also correct only. Some classes are teachers is correct only. Next, all teachers are students. So all teachers are students means here it is wrong. Now one of the statement is going wrong means our diagram is wrong. Our diagram became wrong because we tried to prove first conclusion as false. So in order to prove our first conclusion as false, we made our diagram wrong. It means we cannot prove this as false. When you cannot prove this as false, you should accept that first one is true. No one can prove first one as false. So that's why first one is true. Next, coming to second one, for the possibility, we will be having complete different diagram. So whenever you find possibility in our question, whenever you find possibility in our question, just do like this. Take the conclusion first. Take this conclusion into a diagram first. All schools being students. So all schools being students means first take schools. All schools being students. So I'm taking all schools into students. Okay, all schools into students. This is a conclusion. Now what we should do means whenever you find possibility word, take that conclusion directly into a diagram. Next, what you will do means you just take all the statements into the diagram. If you are able to draw all these statements into the diagram, then it is possible. If you are unable to draw all the statements into a diagram, then this is false. Okay, let us check whether we can draw all the statements into a diagram or not. Coming to the first statement, some schools are classes. Some schools are classes. Some schools are classes. Okay. Some schools are classes. So I'm intersecting schools with classes. This is classes circle. Next. Some classes are teachers. Some classes are teachers. I'm intersecting classes with teachers. Some classes are teachers. Next. All teachers are students. So all teachers are students means again teacher circle is completely inside students circle. So all teachers are students is correct only. Now let us check whether the statements are correct or wrong. Some schools are classes. Schools and classes are intersecting. This is correct. Next, some classes are teachers. Classes and teachers are also intersecting. This is also correct. Next, all teachers are students. So all teachers are students means again entire teacher circle is inside student circle. So this is also correct. All the statements are correct in our diagram. It means our diagram is correct only. Now coming to the second conclusion, all schools being students. So if you observe, all schools are inside students only. So that means it is possible. Yes, it is possible in the correct diagram. So as it is yes, you should take it as true only. If you are unable to draw the statements and if any of the statement is going wrong in a diagram, then it is not possible. But here as each and every statement is correct, second conclusion is true. It is possible. So answer for this one is both 1 and 2 follows. 1 and 2 follows is the correct answer. Okay, is everyone clear with this? Can I go to the next one? Okay, let us go to the next question. Sixth one. We have another two questions left in syllogisms. Okay, next one. So I'll tell you how to solve this one. Whenever this is some special exception case, whenever you find questions like this, suppose if the pattern is like this, you have sum here, you have sum in the first conclusion, you have no in the second conclusion, and also if you have same words here, if you observe the first conclusion you have ball, second also there is ball, so that means these both are same. Next, coming to the second one, in first one we have toy, in second one also we have toy. So like this, when the words are same, words are common, in first one it is ball or toy, next ball or toy. And if you have words common like this, if you have two words common like this, and if you have the keywords like sum is in first one and no is in second one, or no is in first one and sum is in second one, so in this scenario you need not draw the diagram. The answer for this one will be directly either one or two. So whenever you find question like this, just mark the answer as either one or two. So either 1 or 2 will be the answer for that particular model. Once again, I'm repeating, whenever the words are same, whenever you have common words, and if you have the keywords like some and no or no and some, in one it is some, in the other one it is no. And also vice versa is possible. So in first one you have no, in second one you have some. In that scenario, answer for that question will be either 1 or 2. So either 1 or 2 is the correct answer. Okay, next one. Last question in syllogisms. Okay, so this question is something different. So I'll tell you how to do. Whenever you find questions like this, first two are statements. First two are statements and the last one is conclusion. Okay, first two are statements. Last one is conclusion. So you should take each and everything separately. First option is separate, second option is separate, third option is separate, fourth one is separate, and fifth one is separate. Okay, coming to the first one, you should try to draw second and fifth one. So second and fifth, if you observe that one, second, fifth, and first. So second, fifth, and first means you should not look at sixth one. Similarly, you should not look at fourth one. You should not look at a third one. You should assume that these three are not given. You should just look for first one, second one, and fifth one. Okay, so if you observe the first option, 2 and 5. So 2 and 5 means first you should take diagrams for 2 and 5. So 2 and 5 means all fans are bored. 2 means it is all fans are bored. So all fans are bored. Okay, this is our second one. Second statement. All fans are bored. Next, fifth one. Fifth one says that some fan are bulb. Some fan are bulb. Okay, some fan are bulb. So I'm intersecting fan and bulb circle. Okay, next. Coming to the first one, this is conclusion. You should take first one as conclusion. So you should check whether first one follows in a diagram or not. Some lights are fan. We don't have any lights in a diagram. Lights are not mentioned in a diagram. So that's why first one is wrong. First one is not the correct answer. Similarly, you should check for each and every option. First one is eliminated. If anyone got the answer, you can comment it. Next, let us check for second one. So first one is eliminated. This will not be our answer. Now coming to second one, second option. We have 6, 5, and 1. So 6, 5, and 1 means you should take sixth one first. Sixth one into a diagram. So 1, 5, and 6. 1, 5, and 6 means second one is eliminated. Third one is eliminated. Fourth one is eliminated. For second option, you should be looking at 1, 5, and 6 only. In 1, 5, and 6 also, you should draw 6 and 5 into our diagrams. So sixth one. Sixth one says that all lights are bulb. Sixth one says that all lights are bulb. Okay, all lights are bulb. Next. Fifth one says that some fan are bulb. So some fan are bulb. Okay, fan circle and bulb circle both are intersecting. And now in this diagram, you should check whether first one follows or not. So first one in our diagram means it is some lights are fan. Some lights are fan. So here lights and fans both are not intersecting. So as those both are not intersecting, this is also wrong. So second one is not our answer. Second one is not our answer. Next, you should take for third one. Let us check for third option. Okay, third option means you should consider 1, 6, and 4. You should consider 1, 6, and 4. You should not consider the other ones except 1, 6, and 4. You should eliminate all the other statements. Fifth one is eliminated. Second and third are eliminated because we should take only 1, 6, and 4. So in 1, 6, and 4, first you should take first one. I'm speaking about third option, first one. Try to take diagram for first one. Some lights are fan. Some lights are fan. Next, sixth one, all lights are bulb. All lights are bulb. So I'm taking bulb here. All lights are bulb. Now from this two, fourth one should follow. Fourth one says that some lights are Indian. As we don't have any Indian in our diagram, third one is also wrong. Third one is wrong. Next, you should take for fourth one. So fourth one says that 6, 1, and 5. 6, 1, and 5 means you should consider only 6 and 1. First, you should try to draw the diagram for 6 and 1. So 6 and 1 means the diagram becomes sixth one. Sixth one is this one. 6, 1, and 5. So let us take the diagram for 6 and 1 first. All lights are bulb. All lights are bulb. Okay, next. First one, some lights are fan. Some lights are fan. So this is our diagram. Some lights are fan. Okay, next coming to the conclusion, fifth one. Fifth one says that some fan are bulb. Fifth one says that some fan are bulb. So this is the fifth one. You should check whether fifth one follows or not. So if you check for the fifth one, some fan are bulb. Yes, fan and bulb both are intersecting. So as those both are intersecting, fourth one is our correct answer. We should check whether it becomes false or not. So whether it becomes false or not means fifth one, some fan or bulb. So we should try to separate fan and bulb. But we cannot separate fan and bulb. Because if you separate them like that, then automatically first statement goes wrong. So that's why answer for this one is fourth one is correct. Fourth option is correct. Okay, so with this we completed our 7 questions of syllogisms. 7 questions of syllogisms are over. We almost covered all the models in these 7 questions. Next, let us go to coding and decoding topic. This is also another important topic. We almost get coding decoding questions in all the exams we take. So wherever logical reasoning is there, definitely questions from coding and decoding will be in that paper. So coding decoding means A is coded as 1, B is coded as 2, like that. Total A to Z, total 26 alphabets are there. So A is 1, B is 2, C is 3, like that. Based on those numbers, we should answer these questions. Okay, the question is sample is coded as RYJLGY, Maple is coded as LYMHZ. For this, you should try to write the numbers. So if you write the numbers, then you'll get some clarity in this. Okay, let us check for the numbers. So the value of S, I'm writing for sample, S is 19, S value is 19. Next, A value is 1. Next, M value is 13. M value is 13. Next, P value is 16. P value is 16. Next, L value is 12. And E value is 5. So these are the values of each and every alphabet in sample. Next, R, Y, J, L, G, Y. So R value is 18. Next, Y value is 25. J value is 10. Next, L value is 12. G value is 7. And Y value is 25. Alphabets follow cyclic order. So cyclic order means before A, you should take it as Z. Before A, you should take it as Z, and it will be the same X, Y, Z. So again, A to Z will be here, A to Z will be here, like that. It will not end. So again, after Z, it is A to Z. Again, after Z, it is A to Z, like that. So A is before alphabet means you should consider it as Z. Okay, let us check how to do. So 19 became 18. 19 became 18 means they subtracted 1 minus 1. Next, 1 became 25. 1 became 25 means they subtracted minus 2. 1 minus 2. As I said that before Z it is Y, before A it is Z, before Y it is X. So minus 2 means minus 2 is indicating Y, because total 26 alphabets are there. 26 alphabets are there. So you should take minus 2. Next, 13 and 10. 13 and 10 means minus 3. 16 and 12 means minus 4. 12 and 7 means it is minus 5. Next, 5 and 25 means it is minus 6. Like this, they are subtracting. They are subtracting consecutive numbers, minus 1, minus 2, minus 3, minus 4, so on. That is the logic in this. So based on the same logic, you should find for people. So people, again here also it is minus 1, minus 2, minus 3, so on. So let us check how to do. Okay, people, P is 16. P value is 16. Next, E value is 5. O value is 15. Again, P value is 16. L value is 12. E value is 5. Okay, based on this one, let us check. Based on our code, it will be minus 1, minus 2, minus 3, so on. So 16 minus 1. 16 minus 1 means it gives us 15. Next, 5 minus 2. 5 minus 2 means 5 minus 2 is 3. Next, 15 minus 3. 15 minus 3 is 12. Next, 16 minus 4. So 16 minus 4 means again it is 12. Next, 12 minus 5. 12 minus 5 is 7. Next, 5 minus 6. 5 minus 6 means it is equal to minus 1. So minus 1 means it is equal to Y. Because A is 1, A value is 1. So before A, before 1 it is 0. Before 0 it is minus 1. So minus 1 means it is Y. Okay, here it is minus 1. So let us take the values. O is 15. C is 3. L is 12. L is 12. G is 7. Minus 1 means Y. So O, C, double L, G, Y. O, C, double L, G, Y. It is option D. So option D is the correct answer. The logic they followed here is they subtracted -1, -2, -3, so on. Difference of consecutive numbers. Okay, let us go to the next one. Ninth question. For this also, first you should write the numbers. Monkey is coded as BHN QRP. NAP is coded as SDQ. So what I suggest is, as NAP is just a three-letter word, you can take this one first because it gives us an easy way to find the logic as we have only three letters or three numbers. First try to figure it out. NAP is coded as SDQ. Okay, so NAP again we should write the numbers. N is 14, A is 1, P is 16. So these are the numbers for each alphabet. Next, S is 19, D is 4, Q is 17. Suppose in this logic, if we are assuming that here they are adding 1, here they are adding 3, and here they are adding 5, we can take that logic also. But otherwise, if you find, okay, let us go with this. So first it is 14 and 19, they added 5. Let us do the same thing here. We have J plus 5. J plus 5 means definitely we should not have J in our options in the first letter. But we have J in the first letter in each and every option. So it means that is not the logic. So the logic here, what they followed means, if you observe clearly, they applied cross coding in this. Cross coding means first one is coded to the last one. So here first one is coded to the last one. Last one means it is 17. 1 is coded to 4. 16 is coded to 19. So it is cross coding. So if you observe, first one became plus 3 and it went to the last place. 14 plus 3, 17. 1 plus 3, 4. 16 plus 3, 19. So what they did means they added 3 to each alphabet and they applied cross coding in this. Cross means first becomes last. Last becomes first, like that. That is the logic in this. So based on that one, let us check what can be the answer. Okay, first let us write all the values of jute bag. J is 10. J value is 10. Next, U value is 21. T value is 20. E value is 5. B value is 2. A value is 1. G value is 7. So these are the values of each and every alphabet. Next, we should apply cross coding means you should add 3 to each one and it goes to the last one. So 10 becomes 13. 13 goes to the last one. Cross coding means like this only. First becomes last, last becomes first. Okay, next 21. 21, if you add 3 to it, it becomes 24. So second one becomes last but 1. From last it is second. Next, 20 becomes 23. Third one becomes from last if you consider third. Next, 5 means it is you should add 8. So 5 becomes 8. Next, 2 becomes 5. 1 becomes 4. We are just adding 3 to each one. 7 becomes 10. So this is the exact code. Now if you decode this one, 10 value, 10 means it is J. Next, D means it is 4. E is 5. Next, 8 means it is H. 23. 23 is W. 24. 24 is X. Next, 13. 13 is M. So the logic for this one is JDEHWXM. JDEHWXM, which is the first option. So first option is the correct answer. The logic here is they added 3 to each one and cross coding is applied. Okay, I hope everyone understood this. Let us go to the next one. 10th question. Okay, we call these type of questions as Chinese coding questions. These questions are mostly found in bank exams because these are frequent, and also in some recruitment exams like company recruitment exam or campus recruitment exams. In that also we can find these type of questions. So these type of questions are nothing but we should check which of the following is common. Based on common words or common letters, we can answer these type of questions. So let us check how to do. Now, if you observe BIRLENAC, just take which of the following is common. So NAC is common in first and second lines. NAC is common in first and second lines. So let us highlight this NAC. We have NAC here. Similarly, we have NAC here also. Okay, if you observe the right hand side, means after means if you observe the common word there is. Green is common. Green is common. So as green is common and NAC is common, you can take NAC value as or NAC code as green. So NAC means it is green. NAC is green. Next, what we require is tomato is tasty. We require that. So let us check how to find that one. Now, if you observe second and third, if you observe second and third words, HOR is common. HOR is common in both second and third. Okay, HOR is common. Now, if you observe for the common word, in second one we have tomato is green. Next in third one food is tasty. So here is common. Is common. So as is common, you can take HOR code is. HOR you can code it as is. Okay, next one. If you observe first and third, if you observe first and third, in first and third also we have one word common. Okay, in first and third we have dir common. Now, if you observe for words, then BIR means for the first one, green and tasty. For the third one, food is tasty. So here common is BIR means it is tasty. Word BIR here refers to tasty. Okay, so from this we can easily find what is the code for tomato, or we can find the code for green. So let us check how to find this one. Our question is which of the following means tomato is tasty. So is means you should have HOR. Is means we should have HOR. Tasty means we should have BIR. Okay, we require code for tomato. So let us check how to find this one. Find the code for tomato in that. Based on the given options, so if you go with the options, you can find tomato word here. You can find tomato word here in the second one. So is, I'm just cancelling this is. If we cancel is means HOR is cancelled. Next, green means NAC is cancelled. So we are left with only one code and also one word. That one code and one word is tomato. Tomato is pick, PIC pick. So answer for this one is PIC HOR BIR. PIC HOR and BIR is the correct answer, which is there in option C. So option C is the correct answer. Is everyone clear with this? Can I go to the next question? 11th question. In 11th question, I think we have almost of the same thing. Not 11th one. You try to do 12th one first. I'll explain 11th one afterwards. 12th one is almost the same. You should find common letters and also common numbers. Same like the previous one, what we did. If anyone got the answer, you can comment it. Just take all the common letters and common numbers. You should find what is the code for ATP. Okay, let us check how to do. We should find which of the number is common based on the letters. Okay, we require the code for ATP. We should check where A is common. First, let us go with A. So here SAPE. SAPE, here DAME. Now, if you observe those two, there two are common. Two are common in that. So two are common means if you check A is common and also E is common. If you observe the numbers, 9 is common and also 6 is common. So A and E can be either 9 or 6. A or E can be either 9 or 6. Because from the first one and also from the third one, A and D is common. 9 and 6 is also common. So A and D can be either 9 or 6. It can be 9 or it can be 6. Next, if you observe the second one, in second one we have E. In second one we have E. And also in second one we have 9. So that means it can be clearly said that E value is 9 and A value is equal to 6. So as A value is equal to 6, definitely in our answer 6 should be, because A value is equal to 6. Next, let us go for t value and also p value. Let us check where those are common. I'm just writing here e value is equal to 9 because it might be helpful further. So let us write it e value is equal to 9 in this particular question. Next, we are going for t value. So t value also we should follow the same process. You should check where it is common. Okay, t value is common here and also t value is common in this. But we have another value also, another number also common. We have m and t common when compared to the second and fourth. So m and t is common. Okay, m and t is common, and also the values that are common here are, if you observe second and fourth, we have 9254. Here we have 1523. So 2 and 5 are common. So m or t comes under 2 or 5. We should check which one is what. So 2 or 5. Okay, if you observe the first one, just observe the first one. So in first one we have 2. In first one we have 2. We have m. We don't have any t. So that means m value is equal to 2. M value is equal to 2. T value is equal to 5. So we also got the value for t. So it is 6 comma 5. Okay. We should have 6 and 5 in our option. So as we should have 6 and 5 in our option, first one is eliminated. Next, last one is also eliminated. D is also eliminated. So we are left with B and C. We require P value. What is the value for P? Okay. So if you observe the third one, just observe the third one. SAPE. We require P value. We require P value based on the options. P value can be 1 or 8. We should find that one. What is P value in that? Okay. If you observe third one, third line, SAPE is coded as 8369. So we have P in this. We have P in this. We have 8 in that. But we don't have any 1 in that. So that means P value is not equal to 1. So as P value is not equal to 1, C is eliminated. B is the correct answer. Answer for this question is option B. Whenever you find questions like this, just go with the common word or common letter. Then you will be getting the answer easily. Okay, next one. This comes under data sufficiency topic, but in this also coding decoding can be included. We have last 3 questions. So till now we solved 4 questions in coding decoding. 13th one. We should find what is the code for no, no, based on the given statements. So we discussed this topic yesterday. For this, the rule is first you should go with statement 1. Statement 1 alone only you should consider. So if you consider statement 1 alone, we require code for no. Here we have no. So no can be anyone in that, anyone in this 4. Okay, if you observe, we have PA in this. PA is here. PA is also here. But if you compare this one, we don't have any no in this. So as we don't have any no in this, PA cannot be the answer. PA cannot be the answer because we don't have any no in if, none, and but. Next, let us consider LO as the answer. Suppose if we consider LO as the answer for no, Consider this one. Here we have yellow, but here we don't have any no in the given words. So yellow also cannot be the answer. Next, we have NE. We have NE here, we have no in this. But observe the second one, we have NE in this. We have NE in this, but we don't have any no in the given words. So NE also cannot be the answer. When 3 cannot be the answer, then automatically the remaining one, SIC will be the answer for no. SIC will be the answer for no. So we got this from first statement alone. From first statement alone, we got the answer. Now we should check first second statement whether we can get the answer or not. Second statement means you should not consider the first statement. Okay, you should not consider first statement. You should take second statement alone. So second statement alone, and you should get the code for no. We should get the code for no. Okay, let us check. We have LE here. We have LE there also. So if you take that as common, we don't have any no. So LE is eliminated. Next, we have SC also in the second one. SC is repeated, but we don't have any no. So this is also eliminated. Next, NE is not there in that. So NE can be the code for no. Next, SIC is also not there in the second one. SIC also can be the code. Because we don't have any NE in this, we don't have any SIC also in this. So anything can be the code for no. As the answer is not clear, we cannot get the answer from second one. As we cannot get the answer from second one, only one is sufficient is the answer. Only one is sufficient is the final answer. So only one. This is about data sufficiency, which involved coding decoding. Okay, next one. We should find what is the code for water. Same model. What is the code for water? So code for water means again you should go with first statement alone. So first statement alone means the second one you should not consider. Second one is not at all there. From the first one, give me water. It can be anything in that because these are jumbled order. So give me water means it can be 7, it can be 1, it can be 9. So from first one you cannot get the answer. Next, when first one we cannot get the answer, we will check for second one alone. Second one alone means first one is not given. We should consider that first one is not given. It should take only second one. So this I eliminated. Okay, next you can bring water for me. Again here we did not have any common words, so second one alone also we cannot get the answer. So after getting clear that first one we cannot get the answer, from second one we cannot get the answer, then we should combine both 1 and 2 statements. After combining 1 and 2 statements, we should check whether we can get the answer or not. So let us check whether we have any common words from first and second statements. Give me water. So here me is common. Here also we have me, and here also we have water. So me and water both are common. If you look for the numbers, 7 and 1 are common. 7 and 1 are common. So me and water, it can be either 7 or 1. So water code can be, it can be 7. Water code can be 7, or the same water code can be 1. It means we cannot get the exact answer. As we cannot get the exact answer for this one is neither 1 nor 2. That means both the statements are not enough to answer the given question. We cannot exactly tell the code for water. We are confused between 7 or 1. As we are confused and we did not get the exact answer for this one is neither 1 nor 2. We cannot answer this question. Okay, we left one last question. Alpine is coded as 171, Spring is coded as 83, Capital is coded as what? This is the last question for today. Whenever you find question like this, first write all the values of each and every alphabet. Alpine, let us write the code for each and every alphabet. A is 1, L is 12, P is 16, I is 9, N is 14, and E is 5. These are the values of Alpine. Next, let us write the code for Spring also. S is 19, P is 16, R value is 18, I value is 9, N value is 14, and G value is 7. These are the values for Spring. Next, let us write the code for Capital also. C is 3, A is 1, P is 16, I value is 9, T value is 20, A is 1, and L is 12. L value is equal to 12. These are the values of each and every alphabet. Okay, next what we should do means, first whenever you get questions like this, write the values of each alphabet and try to add them. So first we should add what is the alphabetical value of Alpine. So if you add all the values of Alpine, we get 57. We get the value as 57. Next, let us add all the values of all the alphabetical values of Spring. If you add all the alphabetical values of Spring, we get it as 83. This value is equal to 83. Next, similarly, let us add all the values of Capital. Okay, after adding all the values of Capital, we are getting 62 as the total. 62. Okay, now let us check. Alpine is coded as 171, but we have 57 there. So it indicates that that is equal to 57 into 3. It is indicating that 57 into 3 gives us 171. They multiplied it by 3. That gives us 171. Next, they multiplied it by 1 because 83 they gave the same. 83 equal to 83. 83 into 1 gives us 83. So in the first one they multiplied it by 3. In the second one they multiplied it by 1. So let us check why they are multiplying it with 3 and 1. Okay, so it means that is nothing but number of vowels count. In second one we have only one vowel, A, E, I, O, U. In first one we have A, we have I, and we have E. So the logic here is they are adding all the alphabet values and they are multiplying it with a number of vowels. So if that is the logic, then let us check. In Capital we have A, we have I, and also we have A. So we have three vowels in that. That means you should multiply the given value with 3. 62 into 3. 62 into 3 gives us 186. So 186 is the correct answer. Okay, I hope everyone understood this. So in our today's class, we discussed total 14 questions, 7 questions from syllogisms, and 7 questions from coding decoding. All these 14 are important. Mostly we covered all the models in this 14 questions. In our next class, we will be discussing any other new topic. So for today, we are ending our class. Thank you.